I mean, you know, this is just insane performance. Okay, first thing we got to do is open up FFmpeg, shift, right click, open command window here. We'll move this over to this side and then we'll drag in FFmpeg.exe into this command window, and that's just going to copy the path. Make this a bit bigger, space minus HW excels, and that's going to give us these four here: CUDA, DXVA2, and these other two, which we're not really interested in for this. So the next thing we've got to do is determine which encoders are actually available. So as we're already in the correct folder with the FFmpeg binary, we'll just type it in FFmpeg minus encoders, and that's going to give us a list of everything, including the audio. So if we scroll up, this here seems to be broadly alphabetical order. For the demo, we'll use H.264 NVENC, so that's fine. So we'll close that now. This is a video of a bike ride that I did recently. So what we can try and do is edit this down. The program we're going to use is Avidemux, which is essentially a graphical front end for FFmpeg. And as we can see, frame type iframe, and if we now press the up arrow on the keyboard, what it's going to do is take us to the next iframe. So that's 4.166 or whatever it is. So there's essentially three different types of frame: iframe, intraframe, P frame, and B frame. An iframe effectively is a real frame that doesn't rely upon any other frames. P frame and B frame, on the other hand, do rely on other frames. So what we can do, if we now press the right arrow on the keyboard, what we can see, it's gone frame type P frame. We'll do it again, P, 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 P. There might be some B's in there, who knows, doesn't really matter. What's also interesting as well, if we scroll along, what we can, yeah, I mean, you know, this is pretty reasonable, we can work with this, but we'll notice as well, frame type iframe, this doesn't change when we scroll, because that's what the bar is set to do. It will scroll to iframes. If we go back now as well with the left arrow, what we can see actually is there's a very slight delay there, and the reason is because this P frame, which is just loaded, Avidemux has had to load a load of other frames in order to display this. The problem arises when we want to cut sections out. So for example, if I, from this point here, the P frame, if I drop the start point, and if I go up, 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 and then if I press the right arrow, so what we're trying to do is cut on two P frames. So if I now drop the end point and then try to delete this, what's going to happen is we're going to get this error message here. The end point of the deletion is not a keyframe. Video saved in copy mode, it will be corrupted at this point. Proceed anyway. No, we don't want to do that because we don't want the corruption. So what we're going to do is we're going to create an intermediate file using what's known as a mezzanine codec, which is going to be iframe only, and that's going to give us two advantages. Firstly, we're going to have instant performance when we seek on every frame, and it's also going to enable frame accurate cutting, which is exactly what we want. Now, traditionally, what most people would do is re-encode to what's called ProRes, which is almost lossless visually, although obviously it's not, because it's not lossless video. And that's fine. The problem is what's going to happen if we do that is we're going to get CPU usage through the roof, and it's going to slow everything down. So the better solution, we're going to use an intermediate iframe only x264 file. And what's going to happen is, once we've done that, we can load that in Avidemux, and we're going to be using, because the graphics card itself has got a DXVA2 decoder, we can decode that with the graphics card, and what we're going to end up with is effectively instant scrolling and perfect performance. So what we can do, if we close Avidemux now, and then we refer to some documentation on the NVIDIA website, using FFmpeg with NVIDIA GPU hardware acceleration, that's going to give us the code. Hardware acceleration transcode without scaling. And it's given us this line of code here, which is what we're going to use as the basis for what we're doing. So I've got two batch files here. If I right click this one, NVENC one file iframe only, right click, edit. This is Notepad++. We could obviously do this in Notepad as well if we were so inclined. So let's go through it quickly. These two, these are interesting. What they're doing, they're keeping the video entirely in the memory of the GPU as opposed to the system memory. So we're in GDDR6 or GDDR5 memory now, whatever it is this card's actually got, as opposed to DDR3, which is the system memory of this PC. This is why it's so fast. And if we go back now to Avidemux, I mean, we can see here we could have actually used one of these two, H.264 NVIDIA HEVC, and that's going to give us a very similar end result. The problem is the implementation of it in Avidemux, and indeed almost every other program, does not keep the video entirely in the memory of the GPU, which is why the performance of Avidemux with these two is going to be about 1/4 when compared to FFmpeg. So let's go back to the batch file now. %1 in quotes, that is the path to the source file, which we're going to use in a minute with this batch file. And then this here, minus intra, this is, I'm going to use the word native to FFmpeg. This is not an option of the video encoder itself, and it's specifying that we want iframe only for our output video. Now we're going to get onto these. Anything with a (v) on the end, these are parameters of the video encoder itself, which this is the manual for it, effectively, that I created earlier. You can output all options for any encoder that was on the initial list using FFmpeg, and I've done that here, and I've got H.264 and H.265. So if we open up H.264 here, make this a bit smaller, and we can see we've got here all of the options. So if we go back now to the batch file, make this a bit bigger again, we can see, well, unfortunately, I don't know whether it's because I'm using an old version of FFmpeg or I'm on Windows 7 or who knows what, I am effectively forced to use constant quantizer mode when I specify minus intra, which is iframe only. So what I've done is I've specified minus CV, which is codec video, H.264 NVENC, which is the graphics card, minus rate control V0, which is constant quantizer, unfortunately, but never mind. And I've specified the quantizer as 20. The lower the quantizer, the better the quality. And this here is the output file name, which I've specified as %squiggle1.iframe_only.mp4, and I've done that in quotes. Long story short, that squiggle's got to be in there or it's not going to work, because we're going to get double quotes. So if we close this now, what we can do is drag here this source, bike.source, drag it onto NVENC one file iframe only. That's going to load this command window. And this is just insane performance, and this is bearing in mind that we're already recording another stream, which is this video, and we're getting 238 frames per second, even though we're doing that, which is just totally insane, ridiculous performance. Q equals 15, so there's some sort of discrepancy, because I specified 20, but we're actually getting quantizer 15, which is complete overkill in terms of quality. Doesn't really matter, because it's just a temporary file anyway, which we're going to delete. There we go. And then we're going to close this, open that in Avidemux, and what we can see, absolutely instant performance. Furthermore, if we scroll the keyboard, every single frame is iframe, which means we can have a frame accurate cut. So we'll drop that start marker there, we'll go there, we'll cut most of this video out, B, and then delete that, which has left us with a 1 minute video. And as expected, we've got DXVA2 decoding, which is why if we bring the task manager back, even though this is a getting off a 200 megabit video, we've got, 20% CPU utilization, and that's going to be reading the data effectively off the solid state drive that's in this PC. The rest of the heavy lifting is going to be done by the GPU, so it's taken all the strain off the computer and left us with absolutely perfect performance. So, video output copy, audio output copy. What we're going to do effectively is what's called cut without re-encode, which means we're not going to have to wait God knows how long for every single frame to re-encode. We're just going to cut that section out and we're going to save it. So file, save. So let's call this cut video. Troska video file, that's fine. Save. And as we can see, rather than waiting God knows how long, hours, we've cut that video in a matter of seconds, which leaves us effectively now with two options. We could either upload this to YouTube, or we can use the graphics card again to drop the size using a very similar command to the first batch file we did, which created our iframe only video. The only real difference here is we've used VBR rate control and constant quality. We've removed minus intra, and we are going to call it %squiggle1.nvenc.mp4. So if we close this now, drop that cut video on here, and we can see the quantizer's changing. This is because we've specified constant quality as opposed to constant quantizer. It's changing depending upon the motion of the video. We can see we went, going a bit down below 20, a bit up above for some reason. Close that, put that over there, open that up. Yeah, that's come through. Obviously, if this was production, we'd check it properly, but that's good enough for this, so we'll close that. Yeah, easy as that. Everything done in a matter of seconds, all the strain taken off the PC. So there we are. I hope you liked, hope it was interesting, and yeah, hopefully catch you in the next one.